Okay, everybody, we are going to do college algebra section 1.6. Okay, so this is college algebra. It's 1.6, and it's called other types of equations. Okay, so we have something called a polynomial equation. Okay, so polynomial equation. So what if I did something like this, and I had 3x plus 5, and that equals 14. Well, this is a linear equation. If I move the 5 over, so I can move that 5 over, what would I get? I think I would get what? So minus 5 minus 5. I think I'd get 9. If I divide by 3 on both sides, I'm going to get 3. So 3 is going to be the solution to this linear equation. Okay, what about something like this? Okay, so if you were to try to solve this, you can use the quadratic equation, okay? Or you can try to factor it. Either way, it's up to you. But usually you're going to say 2 times negative 4 is negative 8. Then you're going to say 4 times 2 is this. Or we might even have 8 and 1. Okay. And then so we have plus 8 and minus 1. And we divide by 2 on this. And we're going to get something like this. And so we have x equals 4. And we have 2x minus 1 is equal to 0. So this is 2x is equal to 1. We can divide by 2. Great. So we have what? We have the solution of 4, and we have the solution of x is equal to 1/2. Okay. We can also do something like this. We can do this, where we can say x cubed plus x squared. And we can have this equation. So this is a cubed function. Okay, so cubed function, let's see here. What are we going to do here? Well, I can do this and just look at the first 2 terms and take out something. Okay. And then I can draw a little magic box right here. And then write whatever's right here, that's going to be the same thing as right here. Okay, and so you just find the number that you need to multiply this to make this. And so this is going to be this. Okay, great. So what do you do after this? Well, you're going to set both of these equal to 0. So x squared is equal to 4. And that means x is equal to what? X is equal to plus or minus 2. And then I think you also get x equals negative 1. And then there we go. We got it. Okay, what about this? Radical equations. What if I have square root is equal to 9? Okay, well, I can square both sides and make 81. So is 81 the solution of this? Well, if we do this, When we plug in 81, then what do we get? Okay, so this is actually going to be 9 squared. Okay, these are going to cancel. And then you're going to get 9 is equal to 9. Great. Okay, what about something like this? Square root of x to the nth root. Okay, so not a square root, but nth root. And this is equal to 9. Okay, well, you just have to do what? Raise both sides to the what? Nth power. So this is going to be 9 to the n. 9 to the n. So if you had something like this, fourth root of x is equal to 9. Well, that would imply that x is equal to 9 to the fourth. Okay, so what about something like this? Okay, so this is example 3. So this is solving a rational equation. Okay, so what if I have this? Square root 2x minus 1 plus 2 is equal to x. Okay, well, we're going to be doing something like this. This is going to be x minus 2. And then what you can do is you can square both sides. The way I do this is it's this one squared, then this one times this one, so negative 2x, but then double it, so negative 4x, and then take the last one and square it. Okay, so we have 2x minus 1, and that's equal to x squared minus 4x plus 4. I can move this over, and I can move this over. That means we have x squared minus 6x plus 5 is equal to 0. We can always factor this thing. And what are we going to get out of this? X minus 5 and x minus 1. So x equals 5 and x equals 1. And we have to check this, okay? So it turns out if you plug in the 5, this is going to check out, okay? So true. Okay, but if you plug in the 1, let's see what happens when you plug in the 1. 2 times 1 is 2, minus 1, 1. Square root of 1 is 1, plus 2 is equal to 1. No, that's going to be false. Okay, so x equals 5 is true, but x equals 1 is false. And you can check to see if x equals 5 is true because you can plug that in. 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5, and that equals 5. So we just did a quick little mental check there. Hang on, hang on. What's going on here? This is a blank document. Oh, I guess I must have, yeah, something happened. Okay. What about something like this? Okay, so this is example 4. We have square root, we have 3x plus 1. We have minus, this is x plus 4. This is equal to 1. So the strategy here is going to be you're wanting to isolate one of these guys, okay? isolate one of these guys. And then over here, move that one over. So square both sides. So obviously this is going to become free. Then you can multiply this out. Okay, you can collect like terms. So if you collect your like terms, you'll get something like this. 3x minus 4 is equal to 2 square root x plus 4. Okay, and we can actually move over the x and make this a 2x. So let's do that. There's a lot of work involved in this one. Okay, so 2. Okay, great. So we can reduce all of this by just saying x minus 2 is equal to square root x plus 4. And then we can square both sides again. So that's going to give us what? It's going to give us x squared minus 4x plus 4. And that equals what? X plus 4. If we combine all of our like terms, we should get something like this, x squared minus 5x, and that's equal to 0. And if you do this, you should get something like this. So we're going to get x is equal to 0, and x is equal to 5. And since we squared both sides, we have to check our final answers. So it turns out that one of these is true, one of these is false. This one is false, this one is true. Let's check. If I plug in 0, is this true or false? So 0 times 3 is 0, plus 1. Square root of 1 is just 1. If I plug in 0 into here, I get 2. And what do I get? So I get a statement that's just not true here. But what about 5? 3 times 5 is 15, plus 1 is 16. So that's 4. And then we have this, so 4 minus 3. I think that's going to be true. So this is the only solution right here. This one right here. Okay, and this is kind of interesting right here. So I want everyone to look at this. X to the m over n is equal to k. So if you want to solve this, you can do it, but you just have to be careful because it all depends on whether n is even or not. So you would get the exact same thing here. So this is m odd. So m even is plus or minus, m odd is just plus. So why is that? Well, because this is power over root, right? Okay. So this is a power, and this is the root. Okay. So this is power over root. Okay. And let's do something like this. So let's say I have this, x over x to the 3 over 2. This is the power, this is the root. Well, the whole thing is this. If this is the power and this is the root, you know that what? This is m, right? And m is even. So it's going to be plus or minus. But it only makes sense that this is plus or minus because you know that anytime you have a square root, there's a plus or minus, okay? Whereas a cubed root, you don't have the plus or minus. So the best approach here is basically, whatchamacallit, what are we doing? So the problem that I actually wrote down, that I didn't write down, is this. So all you have to do is reverse the exponents here, or flip this is a rational exponent. So you do the reciprocal power. So this is 4 to the 2 over 3, and that means power over root. And yeah, now I'm confused. Okay, so hang on. So in this particular case, this is odd. Okay, so you basically leave it as it is. There's no plus or minus in front of here. There's only a plus because this is odd. So it all depends on how you look at this. However, when I do these problems, I try to just write it in this form right here. This is kind of a weird form to go from here to here, okay? Because you're skipping the step of the reciprocal power, which is right here. So this is what I like to see. So if you're doing this in your homework or whatever, this is what I want to see right here. And then basically flip it, know that this is power over root. As long as your root is not an even number, then you know it's just going to be plus, okay? If your root is an even number, it's plus or minus. Okay, this is example 6. This is x to the 4th minus 8, x squared minus 9, and this is equal to 0. So you might look at this and say, okay, this kind of looks familiar, yet at the same time, it's kind of different. So we haven't really solved a whole lot of x to the 4th polynomials before, and this is kind of a weird polynomial because here's the secret. When the number gets bigger and bigger, it gets more harder and complicated to solve these things. So let's do this, okay? Let's do a little simple u substitution here. So I can rewrite this as u squared minus 8u minus 9 is equal to 0. Okay, and the reason why I was able to get away with that is because u squared is equal to x to the 4th. So we have u minus 9, u plus 1. And let's see here, u minus 9 equals 0. And u plus 1 is equal to 0. Okay, well, we can plug in our x squared term here. And we can start getting some solutions. So what is this solution going to be? It's going to be plus or minus 3. What is this solution going to be? Plus or minus I. Hey, it all works out. And you also have to think. We have 1, 2, 3, 4 solutions. Hey, what's this degree here? Is the degree the same as the number of solutions? Yep. The degree is equal to the same number of solutions. And I think that's called the fundamental theorem of algebra, something like that. Yeah, I think so. Okay, so watch this. Here we go. Okay, now look at this. This is a very interesting problem right here. Very, very, very interesting problem. So the thing is that, how do we do this? We could expand this out, make this huge thing and try to do this. Or we can use the power of a simple substitution. Great, simple substitution. So what is this substitution here? Okay. We have u. Let's see here. We have 5, we have 2. Because 5 times 2 is 10, and if you take these and subtract them, you get this. Okay. So what are you going to have? U plus 5 is equal to 0. U minus 2 is equal to 0. So this is going to be u is equal to -5, and this is going to be u is equal to 2. Okay, and then we substitute our u back in. So we have x squared minus 5 is equal to -5. Well, these are going to cancel, and we get x squared is equal to 0. Then we have, let's see here, x squared minus 5 is equal to 2. Okay, and when we do this, what do we get here? We have x squared is equal to 7. That means x is plus or minus square root of 7. Okay, so these are our solutions right here, and these are our solutions right here. And when you have the same solution multiple times, it's called multiplicity. Okay, so this is a multiplicity rate. So yeah, so multiplicity is basically when something happens multiple times. And then you just list how many times that same thing happened. Okay, what about this? What about example 9? Absolute value, 2x minus 3, and that's equal to 11. So what we can do is we can split this up, and we can say 2x minus 3 is equal to 11. Or we can say 2x minus 3 is actually equal to -11. And we can do that because the absolute value has this property where it can be both negative and positive, just depending on how you look at it. Because if you actually look at the graph, we have a positive x here, and then actually this is a negative x here. So what's interesting is this is the function y equals -x, and this is the function y equals x. So it's split as a piecewise, okay? So this is when x is less than 0, and this is when x is bigger than or equal to 0. So that's how this function is described, okay? So anyway, we have plus 3 here. We have 2x is equal to what, 14. If we divide 14 by 2, we get 7. If 2x is equal to what? If I add 3 to both sides, what am I going to get here? 8, 9, 10, 11, right? So -8. So this is 2x is equal to -8. Okay, so this is x is equal to -4. Okay, and are both of these correct? Yeah, you can, they should be both correct. You can plug them in and check and try them and see what happens.